code in three-phase locomotive and its troubleshooting. In three-phase locomotive, the central electronics in the VCU, vehicle control unit, will control the all operations in locomotive and the feedback from other subsystems, and it will record the fault, various faults related to other subsystems also, and it will give feedback to driver also through VCU. So what it's doing is VC will take some input from various switches and feedback such as relay, MCB, and contactor interlock and a temperature sensor. Similarly, it will take some analog input from angle transmitter and brake system also, and it will take some decision based on the input and its program, and it will give some output which will give to other subsystems for operation such as SR and BUR, and it will also operate some other equipments like VCB, other contactors, which will control some other equipments also. Similarly, it will log the fault and it will take care of loco safety also. The fault code having some format which will include first F will denote the fault, and the first 2 digits is subsystem number. So three-phase loco having 19 subsystems. So 0, 1 to 19, it will vary. Then 0 next 2 digits is for additional information like what fault it is, which will denote the what fault it is. Then next one is P1 or P2, which indicates the priority of the particular fault, which is priority 1 or priority 2. So priority 1 means priority 1 fault is came in DJ will trip, and that fault we need to acknowledge, then only we can drive. But in priority 2 fault, that is not necessary to acknowledge the fault. We can drive the fault. That fault will subside by another fault or another priority 1 fault. So after acknowledgement of priority 1 fault, that particular equipment may get isolated. If it is isolated, that LSFI lamp will glow further. So these are the various subsystems. First one is main power, which is called the priority. Once acknowledgement it will vanish. Otherwise, that screen is another overwritten by another fault, another priority 1 or priority 2 fault. So these are the 19 subsystems. Main power, which include VCB and transformer, those things. Then second, SR1, then SR2, then harmonic filter, hotel load, bar 1, 2, 3, then battery system, brake system, then auxiliary equipment, HV1, HV2, then cab 1 equipment, cab 1, cab 2, then fire dictation, speedometer, FLG1, FLG2 processors, then train bus communication. So these are the priority 1 faults in main power system. Speedometer. It's a subsystem. Speedometer. No. Speed sensor will come in SR. In main power, these are the fault codes. F0101 P1 means VCB stuck in on position. While tripping DJ, if VCB is not getting open, that is the meaning of VCB stuck in on position. In that case, actually what is there for identifying the VCB open or closed, there is 2 interlocks. So these are the VCB interlocks, auxiliary interlocks for sensing that what is the VCB status, whether it is open or closed. So normally it will be in open condition. Whenever DJ closes, it will get closed. So these interlocks are sensed by mounted by this VCU card. So once this interlock is malfunctioned or actually VCB is in staying closed condition or this card having some issue, in that case this fault will come. And it will monitor for some 600 milliseconds. Up to that time it should come. Otherwise that fault will come if it is delayed also. Similarly for VCB in set off also, same interlocks on. Next is low pressure pando or faulty pando. Here after switching on DLPT, PT, ZPT, not ZPT, BLPT, ZPT. Pando not getting raised. In that case, there is a pressure governor. This pressure governor, through this pressure governor, this sensing is happening. Suppose there is no pressure, auxiliary reservoir pressure, there is no pressure. If it is less than 5.6, pando will not get raised. So in that case, this card will sense that and it will give a message. Pando is not getting raised. So there is some reason, maybe MCPA not working, or there is a air leak in pando circuit or a throttle valve somewhere, pipeline somewhere, or the pressure switch may be malfunctioning. So such issues may be. Next thing, catenary voltage out of limit. So we have some design voltage between 17.5 to 29. So that voltage, catenary voltage must be within this range. If it is gone beyond that limit, this fault will come. So this fault is identified by VCU, not SR, through primary voltage first coming to primary transformer. Then it will convert to 25 kV to 200 volt. Further it will reduce to 200 to 4 volt. Then it will go to SR1 and SR2, similar circuit. Then either SR is detected that OIC voltage is out of the limit, then this fault will come. Clear? Transformer oil temperature or pressure not okay. F0105 P1. So here this is priority 1 fault. Here it is 84 is the limit. So oil temperature is beyond the 84. VCB will trip with the this voltage. For sensing this temperature, there is a pressure sensor, temperature sensor in the oil, which is dipped in oil. So that temperature sensor will show the, it will change the resistance of the temperature sensor depending on the temperature, and it is measured by SR, both SR. If it is gone beyond 84 degree, it will give the message. So here sensor may be malfunction or SR sensing side having some issue, then also this will happen. Next is filter on off contactor second. Here harmonic filter having 3 contactors. One is 8.1. This is the main contactor, and next one 8.2. This is adapt contactor. Third one is discharging contactor. So for if both the SRs are working, these 2 contactors should be in closed condition. So only this resistor will come in circuit and this capacitor, and this will be in open condition. So suppose 8.1 is getting stuck in on condition, this fault will come. So this contactor auxiliary interlock is mounted by both SRs. If either SR is by default SR1 will take care. If it is failed, SR2. So if it is find the interlock having some issue or sensing side having some issue or this connection having some issue, either case this fault will have. Next is precharge or main contactor second. This precharge and main contactor is in SR side. SR line contactor side. This contactor SR1 precharge and the main contactor, similarly for SR2. So this contactor feedback also mounted by SR. If it is find, actually this conductor supply is given by SR only. The feedback also mounted by SR. So once given the supply, after that proper feedback is not coming back, then this fault will get blocked. Once SR is identified this problem, it will communicate to VCU through MEV bus, and the VCU will give the pop-up to driver, and that fault also will get logged. Next is primary overcurrent. This primary overcurrent is sensed by SR through this CT. This is the power circuit. Here, return must having two CTs. These two CTs, each SR will monitor the primary current. Similarly, we have some other protection like OCR. So OCR also having similar settings. So any overcurrent is there, OCR will act. Otherwise, this SR will give the message like primary overcurrent is there. So for that, limit is inrush current limit is 800 starting. Continuous operation 330 ampere is the setting. Next one, auxiliary winding overcurrent. In auxiliary circuit, same one. That depends. I think OCR will act first because it's unlocked. This is the auxiliary circuit. Here, two CTs are provided. This CT mounted by SR, both SR. So once the current is auxiliary circuit is drawn current is more than the limit, then fault will come. Its limit is 400 amps. Next one is fractional error, the main circuit. That means more than two subsystems are getting isolated at a time, then this fault will come. Or VCB having some issue, in that case also. Next is priority 2 fault in main power system. First one, over temperature control electronics. Here it is VCU having some thermostat which will measure the temperature of VCU cards and all. So if it is more than 70 degree, this fault will come. Now this circuit is isolated only. This was the circuit, now it is not there. So temperature is more, then this contactor will get pick up. It will get open, so this will drop. In the case it will open, then further 218 will not pick up. This is also circuit, now it is isolated. Transformer oil pressure not okay. Here at least we have two oil circuits. One is mounted by SR1, another one is SR2. So either one oil circuit having some issue, that oil not getting circulated properly, in that case priority 2 fault will come. In priority 2 fault, we can drive the loco further with the available rectifier. Next is air fault in auxiliary winding. In auxiliary circuit, there is a air fault relay. For that, one voltage divider available in input side, and a middle point is connected to air fault relay, and it is grounded. So any terminal, any phase, this auxiliary winding, any phase is there, then one circulating current will flow through this relay. If it is more than 1500 milliampere, then relay will get acted, and its interlocker will go to SR, and it will sense the VCU, and it will sense air fault is there in auxiliary circuit, which is 89.2. Then low frequency catenary voltage and catenary frequency is high. Actually it is designed for 50 hertz, and some tolerance also there. Exactly don't know, some +4 and -2 something. So if it is frequencies beyond this limit, this fault will come. Next is auxiliary capacitor. This circuit actually isolated now. Earlier MRB is in auxiliary circuit, in single phase circuit, not in bar output. No, it is point 0.4 or point 0.4. Now this circuit is not there. Instead of that, this same input is used for FL stamping purpose. Next is demanded speed cannot be achieved. Actually, loco is getting creeping. Creeping is there. Means after giving tractive effort of 50, more than 50%, speed is not getting increased. In that case, this fault will. Next is subsystem 2, SR1. Here, priority 1 faults are S0 to 0 and P1, disturbance in converter. So, whatever life line missing or some other internal fault, whatever it is, power supply issue, in such cases, this priority 1 fault will come, S0 and 0 and P2. Actually, in that case, VCU cannot communicate to SR through MEB. So, VCU will give this fault. Second one, S0 to 0 to P1. Here, SR contactor is getting stuck in or stuck off. In such cases, it will give the feedback to VCU that I'm not able to develop the DC link voltage or something. So I cannot work like that. This issue was there. Contactor having some issue. So this is also priority 1 fault. Next is converter 1 coolant temperature too high. Similar to transformer oil temperature, which is monitoring SR coolant temperature also. SR. So if it is more than 80 degrees Celsius, if it is persists for more than 10 seconds, this priority 1 fault will come. Similarly, coolant pressure also. For pressure, if it is temperature is less than 50 degree, pressure is less than 1.3 for 20 seconds, or temperature above 50 degree, pressure is less than 1.5 for 20 seconds, this fault will come. This values are taken as per ABB limiter. Makewise it may vary, some small variation. Next fault is 0 to 07 P1. The traction motor temperature. For measuring temperature of transformer motor, we have two elements in each traction motor. So if it is more than 210 degree, then tractive effort will get reduced from 100 to 0. If it is more than 215, then VCB will trip and isolation will come. Similarly, either in this two elements, which will compare the values of each element. If it is having some difference of more than 3 ohms, something 3 degrees, 0.3, then also that particular TM will get isolated. Then priority 2 fault in SR. Earth fault in converter. So each subsystem having some air fault sensor. So inside SR also one air fault sensor is there. So inside SR any component, any circuit anywhere earthed, then SR will dictate that through that sensor, and it will give feedback to VCU. Then it will give the fault. Next is traction motor overspeed. Similar to temperature, each motor having some speed sensor also. So that speed sensor is mounted by both SR. So SR1 is monitoring speed of TM123. Similarly, SR2 456. So if it is find some speed difference between the TM, then this fault will come. Next is MUB resistor too hot in converter 1. The MUB resistor means after creating DC link, if DC link is, we have to keep the DC link voltage in a constant or normal value. If it is gone beyond the limiter, for as a safety, we need to reduce the voltage. For that, we will activate the crowbar circuit. So OVC means one over voltage protection circuit only, crowbar circuit only. Once that crowbar is activated, that higher voltage will chop like through one resistor. It will chop that voltage through one resistor. It will get dissipated. So once activated, that resistor will get hot due to that higher current. So In that case, this knob resistor too hot, this message will come. If it is oftenly actuated, actually there is no temperature sensor, but if it is frequently operated, then it will give this message. Similarly, faulty motor temperature sensor. This is already told, no? TM temperature sensor. Then equipment temperature, and both are having power components like IGBT and all. So which is mounted on heat sink, and that heat sink temperature is mounted by SR control system. So SR finds that that temperature is more than 80 degrees, then this fault will come. Hmm. Hmm. T2, this difference, it's all no, 0.3 difference in such case. Or if it is open circuited, one element, or short circuited. These faults are already discussed in SR1, similar one, priority 1 and priority 2. Next, harmonic filter. Such one harmonic filter current is too high. Its limit is 410 ampere in normal operation. In rush current is 600 ampere. So here also in harmonic filter circuit, we have two CTs. These CTs are mounted by SR1 and 2. Next is harmonic filter contactor, second of course. So earlier we told 8.1 contactor. Similarly, 8.2, 8.41, any one contactor feedback is not getting properly to SR, then this fault will come. Here also that resistor, harmonic filter resistor, if it is getting overheated, means there is no temperature sensor, it will dictate it is through its operation only, cycle of operation. Suppose that filter is operated within 15 seconds of previous operation, then either in that case, otherwise within 145 seconds, if it is operated 15 times, then also this fault will come. Priority to fault, at fault in harmonic filter circuit also one earth fault relay is there, similar to other circuit. One voltage divider and middle point is got earthed. So either terminal is earthed, that circulating current will flow through this relay. If it is more than 1500 milliamp, this fault will come. Then hot load. In hot load also earth fault relay is provided. So any earth fault is there inside the hot load, that will give the one digital input to VCU, like the 110 supply. So if it is 110 supply is available to VCU, it will give this message. Hot load having some. Next one is overcurrent in hot load circuit. That limit is 800 ampere. So there is a CT outside the hot load input winding. So this one mounted by SR. If it is find the current is more than 800 ampere, this fault will. Then priority 2 faults, hot load contactor stuck on. Then hot load having one output contactor. After closing that contactor only, the supply is going to coaches, power car. So that contactor is properly working or not is mounted through its feedback, that auxiliary contact. So that auxiliary contact not getting close to properly or contactor having some issue, then such issue will be problem. Then burr. Disturbance in processor burn. First, as earlier we told, SR having some lifetime missing issues. Similarly, burr having some lifetime issues, power supply card issue or other internal fault, or VCU unable to communicate to burr, then such issues will come. Next is auxiliary fault in auxiliary converter. Means burr is lifetime is okay, but burr cannot develop the output voltage. due to some rectifier fault or inverter fault. In such case, this fault in auxiliary converter will come. In that case, it will communicate to VCU that inverter having some issue or rectifier having some issue like that. Next is converter fault in auxiliary converter 1 or HV1. This is actually bar is closing, operating some contactors for load sharing purpose. So those load sharing contactor feedback also is monitored by bar. If it is not properly coming, like 52.5 or 52.4 is not getting closer properly, or it's not opening, it's getting stuck in somewhere. In that case, this fault will come. Then ventilation. Similar to SR, this one also monitoring the inside power module temperature. If it is more than 80 degree, this fault will come. Then priority queue fault. Priority 1 fault in okay, similar only. Bar 1, bar 2. Then battery system. The priority one is first is 82. Battery voltage is below 82. Then actually bar 2 and bar 3 both are monitoring the battery voltage. By default, bar 3 only will take care of the battery voltage. If it is below 82 volt, then it will give the priority one fault like S0901 PM. Then S0902 P1 is battery voltage is below 86 volt. Then Pando lowered longer than 10 minutes. If it is after switching on BL key in driver mode, Pando not raised, and if it is gone more than 10 minutes, then VC will shut down the system for sleep mode, for saving. So that is a Pando lowered longer than 10 minutes. Then priority queue fault. Here it is battery voltage low is 92 volt. But in 92 also we can drive the loco. Battery charger MCB off. Here MCB having some feedback with MCB 100. That is monitored by bar. If it is not coming, then this fault will come. Then low battery charger current. Here two CTs are there inside the charger. One is for monitoring the battery plus load current. Other one is for battery current. So if it is this battery current is lower than 10 amps, means battery is not getting charged. In such cases, this fault will come. In that case also actually that is designed for it will be more than, in that case also it will be more than 10 amps. So last time Leroy we got in 22 amps, then we reduced it to 7. In that case also message will come. If it is current is less than 10 ampere, message will come. In this fault is for a Mika lock only. In Mika CCU, earlier one DA card is there. There one RTC battery will be there. That battery voltage is drained means this fault will come. Now it is not there. Then air fault in battery circuit. This is the battery circuit. Here one air fault relay is there. Through this relay, it will sense the air fault in somewhere in control circuit. Then this fault will come. Then brake system. The brake system, logners are told he will take in another day. That's why I'm speaking. Then auxiliary machines, auxiliary cubicle HB1. Here MCB, our auxiliary motors are controlled through some MCB. So this MCB feedback is whether it is stripped or not. That feedback is going to VCU. So VCU once any MCB stripped, concern, then that particular message will come. MCB tripped in auxiliary cubicle. Similarly, at fault in 415 bar 110 supply. For 415 110 supply, we have one transformer. Here, one air fault releaser, 89.5. If any air fault is there in this circuit, this particular fault will come. Actually, this MRB circuit and all not available right now. This is older circuit. Next is MCB of main compressor open. So MCB is operated through 47.1, MCB1 and MCB2 for 47 bar 2. So these MCBs are stripped, then fault will come. Then lockwise in shunting mode. For shunting mode operation, we have one switch, programmable switch. If we keep in shunting mode, this fault will come. Right. Yes. Hmm. This is similar to HP1 also. Then carbon. The carbon operations are mounted by HBB and HTB processors. So if there is any lifetime problem or some power supply issue, that processor are unable to communicate to other, means this disturbance in HBB1 or HTB1. Similarly, reverse are defective, means forward and both forward and reverse input is coming at a time from particular cab, then this fault will come. Similar. Then FTU, firing machine room. In FTU, we have two inputs. One is for fire alarm, then warning, then fault. If FTU having some failure, then it will tell that the FTU is malfunctioning. Fault in FTU, like that. So this one for P1, priority 1 fault. This one for P2 fault just for warning, and this one for FDU itself malfunctioning. And these are the priority 2 fault. This one priority 1 fault, priority 2. Then speedometer. The speedometer is giving some feedback to VCU like 105% of the maximum allowable speed or 110%. For WP7, it is 130 kbh, 130 or 140. 140. So 105% of 140. If it is gained 105%, that particular interlock will get closed in speedometer 105%. Then that feedback is mounted by ECU. Similarly for 110 also. Actually these two now isolated, it is not using, but this healthy speedometer healthiness is mounted by ECU. This is for healthiness only, T2 volt. An FLG1 processor. Here also FLG1 not working properly or is not unable to work due to some internal issue or power supply issue, then lifetime missing issue. Similarly, software mismatch issue, actually FLG1 and FLG2 will have some software. No? So both having some mismatch, in such case only this fault will come. Suppose some FLG card is changed, that changed one having some different software and other FLG having some other software, then such fault will come. Fault in angle transmitter of sort. This is the angle transmitter. Here having some 4 digital inputs and one analog output. So this first one is for traction side, other one is braking side. These two interlock will tell that whether it is in 0 position or 1/3 or 2/3 or maximum side. Similarly, according to the position, this angle transmitter giving some output current also. So these two will compared by VCU. SR, sorry, VCU will compare these two values if it is having some mismatch, because this 1 by third question will have some particular current, 2 by third will have some other current. So if there is any mismatch between these two, then it will tell that angle transmitter is faulty. Then disturbance in DIA card is also for Mika's logo only. Same only, FLG1 and FLG. Train bus. No, this train bus is actually in Mika's logo on ZB card is there. That will take care of the communication, this train bus communication. Similarly, in TCN VC also, repeater card is there. So this will take care of the train bus communication. Some that card is having some issue, then train bus communication failure, some this fault will come.